So let's get started. I'll walk you through a journey that we took at LinkedIn exactly about this time, November, December timeframe last year. And so before I get into the details, I would talk about why we started looking at this landscape of distributed databases. And so very quickly, we have got quite a few data stores at LinkedIn already, Espresso, we've got Oracle, you also have MySQL, and Pinot and a bunch of other things, right? So this, looking at the Espresso, which has served our needs very, very well for many decades, it scales very, very well, but doesn't quite provide consistency. As for Oracle and MySQL, they're consistent, but they don't scale out. So we have need for a bunch of applications where we need consistency, but without having to, we have to scale out without having to compromise consistency. So there clearly, we identified there's a need where we need a product that can give us the scale and also consistency. Now, there are a bunch of other things that I have listed here as the requirements. I will not quite go through them. Those are basically to do with operability, and that's a bit of boring stuff. So I would rather go to more interesting stuff, and also in the interest of time. So we started with a short list of open source offerings in that space, and those are basically CitusDB, CockroachDB, OceanBase, TiDB, Vitess, and Yugabyte. One note over there, Vitess is not quite a distributed SQL. The reason we put that in the list is because Vitess is already in the LinkedIn ecosystem, right? So it made sense also to basically evaluate that product, against the same set of criteria, right? So I'll walk you through basically now what was our core philosophy for the evaluation. And it was basically, we want to gather insights, not output. It's very easy to go run a whole bunch of tests and collect QPS, latency, and God knows what, and not be able to decide what that even means. So we pivoted very strongly towards generating discriminating insights that help us make a decision, and quickly. Our goal was to decide within 1 quarter, right? So philosophy there was fail fast, exit early, right? Now, next up, I'll talk about what were the insights we were looking for? What were the engineering outcomes to be able to make the decision in the order of priority? I think you have to know basically what the priority is, what really matters, right? So first up is the consistency, because if a product is not going to provide consistency, why bother, fail fast, exit early, right? Now, other thing is that we wanted to measure consistency as a number, not as something which is a gut feel, right? One note over there, we did look at the Jepsen tests out there, which is published, which looked very good for these products. Now, the consistency here was meant to measure the consistency need for the use cases we have at LinkedIn, right? Next up is the performance, second priority. There we wanted to basically measure what is the throughput we can get per core, right? Without having to compromise the quality, right? So when I state over here, let's say we got X QPS per core, what that means is where latency doesn't do the hockey stick, right? And the scale factor is nothing but slope on that curve. I will show that graph very soon. Resiliency, that's the third priority. And resiliency matters because operability matters. I would argue for a product that's a database, that's consistent, and that scales out. Scale there is a feature. You have to have that's table stakes. But resiliency is something that's important because this product typically has life measured in multiple decades, right? So you want to have a product that is super operable, right? And again, we are measuring here specific numbers. what is the specific scenario, and if there is an impact, then how much is the impact. And we made a distinction between planned event versus unplanned event. And rationale for that is the planned events are, think of like maintenance, think of OS patches, think of software upgrade. Those events are generally 10 times more frequent than unplanned events. So we made a clear distinction there for that reason. Now, you might wonder why architecture is the fourth priority. It does not mean that architecture does not matter. Architecture matters a lot. The only reason architecture is fourth priority is because it is a bit subjective. Unlike the top three, which are measured as numbers, architecture is somewhat subjective, right? And nevertheless, the idea there was to not only find out what is the architectural strength, but also to figure out what are the top 2 or 3 huge problems, big rocks on the product's roadmap, right? So last track is not about the evaluation, but we ran this track in parallel to the evaluation, and rationale for that was we so did not want to do the evaluation and then go on yet another fishing expedition to find out our pilot use cases. Because experience shows, however exciting the product might be, and you probably get a bunch of use cases, right? But typically, people are hesitant to become the first use case, right? So we wanted to hit the ground running, right? Now, the idea, and we also wanted to be very agile about this evaluation. Idea was to have the focus. Focus basically means what I already described as those measurable numbers, quantified numbers. That's the focus. And freedom is about being able to use the tool, the underlying tool, whether we use YCSB benchmark, whether we use TPC benchmark using, let's say, Sysbench, which is what we ended up using. That was the freedom given to developers. But focus was very clear as to what insights we are looking at producing. And repeatability, of course, it matters, because unless you can repeat your test cases, repeat your test results, it does not count. So generate insights, not output, fail fast, exit early. So now I will speed up, take you very quickly through this thing. You guys are ready? Okay, so this was a bit like a horse race. So now, first up, we ruled out Vitesse, because Vitesse did not quite pass our consistency tests. We saw a bunch of failures. Now, CitusDB, it looked a pretty good product. I think it has got a very good future, but it is too early, too young in its journey. Next up, CockroachDB. CockroachDB is a great product, but it is not fully open source. Even features like backup and some of the basic things also are part of the enterprise license. So, and we at LinkedIn believe in going with the open source. So that's the reason why we ruled out CockroachDB. OceanBase we ruled out because OceanBase was built even before the RocksDB was built, and OceanBase was built even before the Raft that came out in 2014 and has become pretty much standard since then. So, and OceanBase also couples the stateless SQL engine, SQL layer, with a custom storage engine, which is not RocksDB, because it was built even before RocksDB was invented. So for that reason, we ruled out OceanBase. So now we were left with TiDB and Yugabyte. And it was a pretty tight race. Both of them looked pretty good. And for a while, we thought that you could not go wrong with any of these products, right? So now I will present basically, so what was the discriminating insight that helped us make a quality decision? Before I give data point, I'll just talk about the workload. We were simulating Espresso workload on the Espresso SQ, which is 20 physical cores, hyper-threaded, with 256 GB RAM. Our workload being 90% read, 10% write, 2 KB payload size, pretty much OLTP workload. And we used sysbench with the TPCC benchmark. Except for consistency and resiliency. For consistency and resiliency, we used synthetic workload. And that distinction is very, very important. If you are doing a performance testing, I would argue that workload has to be representative of your production workload, in this case, espresso, right? But if you are doing consistency or resiliency, all the time, I would argue you want to make the workload very, very synthetic, because idea is to precipitate the issues. Idea is to find out the problems. Idea is to basically generate discriminating insights. Now look at this chart, which was super useful in us making a decision. This was a small cluster where we ran the Yugabyte test, exact same workload that we ran on the TiDB and the Yugabyte. In case of Yugabyte, if you take down a T server, any T server, and this is with the synthetic workload, the QPS drops all the way to the floor for about few seconds. There is outage right there, right? So, whereas when we did the exact same test against TiDB, we see the QPS drop by about 10%, but we do not see impact like that. So that's where we started forming some opinions about, in favor of TiDB. And now, in case of TiDB, if you go kill a TiKB node, like I said, we see maybe 10% QPS drop, but QPS does not drop all the way to the floor, with one exception. In case of TiDB, we see some impact if we had to take down the PD leader. If there is an outage on the PD leader, we see about 3 seconds worth of impact. And I believe this thing is being worked by the PingCap team, and they made some fixes in the upcoming release, 7.7.x, I would say, which we have not tested yet. Now, this is coming out of our performance track, the scale factor. In this case, the x-axis is showing basically the number of hosts, and the y-axis is showing you the throughput that we achieved. And this thing is scaled very, very linearly up until about 32 hosts. That's where we get about 2.2 million QPS, right, on the Espresso OLTP workload. And after that, it doesn't quite scale after that point, but till that point, it scales very, very linearly, right, which looked pretty damn good, in my opinion. So the winner is, I think it's obvious by now. So now I have talked about consistency, I've talked about resiliency, performance, and scale factor. So now you can see all those numbers side by side, Yugabyte compared to the TiDB against the same workload. Consistency, we are happy with both the products. For resiliency, if we look at the Yugabyte, we expect that to cause issues even in case of planned events. And if we account for that, it leads to 4-9 system, right? Whereas in case of TiDB, we expect that will be a 5-9 system just accounting for the planned events. Performance is about the same, 60,000 per box. It's about 3,000 for physical core. Both products with the same number. And for the scale factor, we did not bother measuring a scale factor for the Yugabyte, because Yugabyte it can scale, but it requires some human toil. And the reason is, as we discovered in our architecture track, that for Yugabyte, there is no separation of the SQL layer from the storage layer. The T server combines the PostgreSQL engine along with the RocksDB, along with all the 2PC protocol that Yugabyte team has built. Whereas in case of TiDB, there is a clean separation of stateless SQL layer from the underlying stateful TiKB layer. One note over here, probably shouldn't be surprised to people who are using TiDB, that the one issue that we found with the TiDB is in its usage of the timestamp oracle, right, with the PD leader, that does become bottleneck. the graph that I earlier showed about the scale factor, the bottleneck is with the PD, and it comes from three sources. One is the TSO, and other source is the heartbeat for different raft groups. And third is the scheduling, which will not happen during normal operations, right? So again, I believe the PingCap team is working very hard to optimize, away those bottlenecks. So now I will, So these two are the use cases coming from our use case discovery track. As I said before, that as we were doing evaluation, it was super, super important for us to also have found out basically the top use cases which we want to onboard as part of our pilot. And we picked, our real use case here actually is LMS, and I've got Barry from LinkedIn right there, who heads that team. And I would say that LMS is the real use case for us, because LMS is a very critical use case. It generates a lot of revenue, for LinkedIn. It stands for LinkedIn Marketing Solutions. But LMS did not want to become the first use case, right, as we were suspecting. So we prioritized the enterprise platform use case, which basically is used by our recruiters, LinkedIn's recruiters, where we give them some recruiter seats and stuff like that. That's also a critical use case. And our plan is to put AP in production by the end of this year and gain useful, important, critical operational experience with the TiDB, which will help us build confidence so that we can go put LMS in production by the middle of next year. I know it's very aggressive, plan. And what is helping in that journey is that TiDB's wire protocol is MySQL. So what that means is, and MySQL already has huge presence in LinkedIn's ecosystem. So we can take all of our ORM, that's Juke, and all of our client tech stack gets decoupled from the server technology. And we have both EP and LMS team work in parallel against MySQL. And right now, as I speak over here, we are integrating both EP and LMS. Now, around this time, they are running their application against TiDB cluster. But up until now, they have been doing work in parallel independently against MySQL wire protocol. That's a big deal. So I think that's the end of my talk over here. And I'll leave some time for the questions. Thank you.
Great presentation. Appreciate your, deep evaluation and methodology. One thing which looks like extremely fishy to me is exactly same performance numbers. Mm-hmm. Because for systems with so different architecture, right, as you highlight, it would be very strange to see that.
Yeah. So thanks, Peter, for that question. Those are numbers a bit rounded out. Number for the Yugabyte is slightly higher, but not that much higher. Maybe about 64 or 65,000. However, Yugabyte, I expect the performance actually goes down as you scale out the cluster. So, and other reasoning is, generally in my mind, I would say, if you have an architecture where your architecture is a bit like monolithic, you have coupled storage layer with the SQL layer, I'm okay to go with that architecture provided two conditions are met. Your performance has to be 50% more, much more to justify a coupled architecture. And second constraint is, if you have a reasonable plan of separating out the SQL layer from the storage layer, looking at the Yugabyte's code base, we did not get that confidence that that's an easy task. Thank you.
Thanks a lot for the presentation. I was just interested in, did you try this on some specific hardware, or is it just like, it doesn't matter, like you had everything kind of general purpose environment?
Yeah, good question. So we ran this thing on the exact same hardware on which we run Espresso today in production, which is about 20 physical cores, 256 GB RAM. And we also ran the baseline basically MySQL running on the same hardware. For comparison purposes, MySQL does 230,000 QPS, but that's not including the replication cost and stuff like that for comparison purposes. Does it answer your question?
Yes, thanks.
Okay, thank you.
Yeah, in your performance test with the TiDB, it seems like at certain cases, when you add more machines, the performance drops instead of like monotonically increase. Can you talk more about the reason? Like, it seems hard to reason about like how, like if I want to come to a conclusion, expand the cluster will expand my capacity. That graph seems not the case.
Okay. Like this graph over here?
I think it's, yes.
Yeah. So what is happening here is up until the 32 host, it scales linearly. And after that, we run into the bottleneck with the PD leader, which gets bottlenecked on the TSO, timestamp oracle, and the Raft heartbeat. And it stops scaling after that.
Yeah, but at 50 hosts, like it seems the performance increased again. So that's something like.
Yes. So the thing is, it is so my argument here is that it scales linearly up until 32. After that, it doesn't quite scale. So internally, the way we are publishing this number is that this will scale up until 32 hosts. After that, performance is not predictable, and so we'll have to go fix those bottlenecks before we can scale the cluster further out. And yeah.
May I ask, like, how large, how many data a host can host, like in your hardware?
How many data hosts?
Yeah, basically each host has how many disks, and each disk is how large?
I think it's about, Ashish, you know the number?
One SSD, 3 terabytes.
Thanks.
How many disks would be in a server?
I think
The number of disks in a server, or is it just one disk per server?
Ashish, do you know that? One disk. I think that generally is not a concern because in this case we're expecting we can always lose a host in this case, in this architecture, given the quorum setup. Right.
Follow up on this, is this like a multi-region configuration or it's like a single region?
No, that's a single region configuration. Okay, so if no more questions, thank you all.